Good morning, Knights. Welcome back to Chemistry Online. So today we're going to be talking about the assignment that I gave you guys last class. Not very many of you did this assignment, but those of you who did an excellent job. I thought y'all did great. Let's go ahead and take a look at it. So when we started last class, I told you guys that there were ionic and covalent compounds. Covalent compounds are more difficult to name. So here we have two lithiums. If this were a covalent compound, it would be dilithium. So the numbers actually matter when we're talking about covalent compounds. But when we're talking about ionic compounds, these numbers don't matter. So these are actually easier to name. So here it says we have binary ionic compounds. So with ionic compounds, we're not going to use any prefixes like di or tri. Next, we have the binary. So what does binary mean? Binary means two. So when we're talking about computers, binary is going to be the ones and the O's that computers use to communicate. But in this case, when we say binary, we're talking about two elements. So lithium and fluorine, that's binary. Lithium and oxygen, that's binary. So let's go ahead and work through these. So first one, easy. If we look at the rules that I gave you guys last time, you always name the metal first, and the metal is always going to be the one in the beginning. So you name the metal first, and then you just add an IDE to the non-metal. So in the case of this one, we have lithium fluoride. Next one we have is going to be lithium oxide. And then next one's going to be lithium phosphide. And then BeO, so that's going to be beryllium oxide. All right, that's going to be BeRyLlium, oxide. Next one is going to be boron fluoride. All right, the next one we have is going to be boron bromide. Then we got boron nitride. And what do all these have in common? You name the metal and you write it as you see it on the periodic table. And then the non-metal, you always add an IDE. So you take the root, which is fluor for this one, you add an IDE. Oxi for this one, add an IDE. And some of them are intuitive, some of them are not, like oxygen turns into oxide. And you just get used to working with these, and in the future you're going to know oxygen is oxide. Nitrogen is nitride, bromine is bromide, fluorine is fluoride. All right, so here we have copper fluoride, copper oxide. So here, so what changes here with number 15 is now we have our, we're using transition metals. And when you're naming elements that have transition metals in them, you always need to write in parentheses, that's what you see here. You need to write in parentheses the charge that's on the transition metal. So let's go ahead and do that. So to do that, you're going to need to know how many, for this one, it's pretty easy. So fluorine has a charge of -1. So let me write out the charges. So we know this is +1, +2, +3, plus or -4, -3, -2, -1. So here copper is attached to a fluorine, which means copper has a charge of +1, because this is -1, and we know that this wants to be neutral, so this has to be +1. So what you're going to write here is going to be copper 1 in parentheses, and then fluoride. Here we have copper 2 and then oxygen. Oxygen we know is -2. And because we have 2 coppers, then we know that copper also has a charge of +1. Because we have 2 +1s that make this -2 a neutral charge. Because in the end we want it to be 0. So this one's also going to be copper 1 oxide. And then this one, so nitrogen has a charge of -3. And there's 3 coppers down here, which means copper has a charge of +1. I won't write this one out, but that's going to be copper 1 nitride. So here, let's take a look at this one. So here we have copper 2 chloride, and it wants us to write this one out. So let's start out with the chlorine. So chlorine has a charge of -1. And then here, our copper has a charge of +2. So Cu has a charge of +2. So how many chlorines do we need in order to bond to this copper? It's going to be 2. So 2 chlorines, which have a -1 charge, are going to bond with this +2 charge to give us, to equal out that 0 that we're looking for. So here you're going to write CuCl2. All right, next one we have copper 2 oxide. So we know oxygen has a charge of -2, and then copper here has a charge of +2, which means this one's just going to be CO because they're already neutral. Here we have copper 2 nitride. So this one for most people is the most difficult. So copper, that's a Cu, but copper has a charge of +2 here, and then nitrogen has a charge of -3. So nitrogen is -3. And what we're going to do here is the crisscross method that I showed you guys last time. So the 3 goes here, and then the 2 goes here, and then that leaves us with Cu, oh, that should be a U here, Cu3, and then N2. But it's not that much more difficult than the ones before it. All you're doing is the crisscross method. So let's go ahead and get this one. So here we have sodium oxide. Here we have sodium nitride. So sodium's over here, has a charge of +1, and then nitrogen has a charge of -3. So Na is going to be +1, and then nitrogen is going to be -3. So how many sodiums are we going to need per nitrogen? We could just do the crisscross here. So bring the 3 down here, bring the 1 over here. And then when you write them out, you don't need to write the 1. So this is going to be Na3N. All right, PbF2. So here we're going to start out with writing out our lead. So lead is a transition metal. It's right here. All right, so here we have lead, and I know lead is in the group 14, which is ±4, but it's an exception. So this one is a transition metal. Lead is a transition metal, and here it's attached to 2 fluorines. Fluorines have a charge of -1. So let's start with that. So fluorine is -1, and we have 2 fluorines, which means we have a total negative charge of -2. Which means our lead, our Pb has to be 2. So Pb has to have a charge of +2, which means we're going to write lead 2 fluoride. Here we have PbS, and sulfur has a charge of -2. So this one's also going to be lead 2 sulfide. So here we have 1 sulfur with a charge of -2. Here we have 2 fluorines with a charge of -1, which is why both our leads are going to be 2s. So the next one, this one looks a little bit more difficult. So Pb3N4. So in this case, our nitrogen has a charge of -3, and then there's 4 of them. We just do the uncrisscross method, so you can see that 3 here, which means lead probably has a charge of 4, but we could also do the math. So with a charge of -3, we have 4 of them. So 3, 6, 9, 12. We have a total negative charge here of -12. And our lead, we have 3 of them. We need to know how many we'd need in order to have a +12 charge. So 3 times 4, so +4, would give us our +12. So 3 times +4 gives us +12. So this is going to be lead. So this is going to be lead 4. It's going to be IV. Lead 4 nitride. Yes, that one was correct. All right, so I'm gonna go ahead and stop at 28. So we'll do the next few, and then I'll stop, and then you guys will be able to work out the rest on your own. I didn't leave y'all very many to do, but I want you guys to work through these yourself. So next one we have is lead 4 fluoride, which means our lead has a charge of +4, and fluorine we know has a charge of -1. So how many fluorines do we need to attach to this lead? It's going to be 4. So it's going to be Pb and then F4. All right, next one, lead 2 sulfide. Sulfur has a charge of -2. So how many -2s are we going to need to attach to this +4? It's going to be 2. So PbS2. Next one is lead 4 oxide. Oxygen has a charge of -2. And lead has a charge of +4 here. So we're going to need 2 oxygens to attach to the lead. So that's going to be PbO2. And that's it. I think that's a good stopping point right there. I'll see you guys next week. Have a good weekend.